Hey, good morning, welcome back.
Morning, sir.
Alright, so quick safety before we start. Review, we have the active shooter button or the panic button. How does that work?
Press right button, sir, and door locks.
Okay, which doors lock?
Both of these two, sir.
Nice, yes, all the doors will lock. You can't come into the building. Can you get out? Yes, you can get out. Then how do you know that it is depressed?
Red light.
Right, good job. So once you depress that button, what else should you do?
Call 911.
Why is that? Right, yeah, so you gotta remotely open the doors, good. Okay, and in case of like a fire or any other emergency, you would just leave the room, go down the staircase, and muster by the tennis courts, and get accountability there. Any questions?
No, sir.
All right, good. All right, so before we kind of get into what we're gonna talk about today, here's your quiz. Just answer the first one, so you guys can go ahead and take a piece of paper out. Answer that first one. I'll give you about a minute. You don't have to describe your operation, just be able to list two of them. So I'll give you a minute for that. Okay, one of them rhymes with mama meter, meter. You use it whenever you have a fever.
Sir, Gonzalez, from 1 and 2 and helps that 2 of them.
It's exactly what I
Shot
did.
at it? Okay. If you go lick, you get no point for shotgun. You got about another 10 seconds.
It was just the first question, sir.
Yeah, just the first one. List 2. All right, time's up. Go ahead and pass it to the right. And I will collect those.
I have 1 line 2 of my answers, sir, so they're crossed out. But 2 of them are there.
Good. Well, take the behavioral quiz, and if you bomb this one, you can swap them out, right? All right, go ahead. I'll take those. Thank you. All right, so let's go with the first one. Who can list one? Barometer. Okay, yeah, barometer's on there.
Thermometer?
Nice. What does the barometer measure?
Barometer measures.
Pressure, good. What else you got?
Radar on there, sir?
No.
Laser rangefinder?
Thermometer?
All right, barometer, right? Thermometer, barometer, thermocouple, common gauge, right? Expansion thermometer, all these things would have been okay. Hopefully you listed those in your quiz.
1 line there.
All right. So why should you care about measurement, right? So where's my aviators at? All of you. Okay. So why should you care about measuring temperature, measuring a pressure, measuring an altitude, conversion, unit conversion? Why do those things? Why does that matter?
And
To you.
affect the effectiveness of your equipment.
Okay. Okay. How's it working? Is it working properly? Good. What else?
Sometimes you can't fly in like certain weather conditions, so you need to make sure everything's aligned.
Right. So also in the instance of a casualty, the first indication, right, it's kind of like symptoms, right? You're looking at these, you're measuring these parameters to see the symptoms. If you go to nuke, you're monitoring plant conditions to see the symptoms of plant. Good. All right. So these are the objectives. So be able to comprehend the importance of unit conversions, right? So metric and to the standard system. Why does that matter? We do calculations. If you're doing the wrong, using the wrong system, your calculation is going to be off, right? And we'll see some examples of how that happened and how it went bad. Be able to comprehend the operation of some of the instruments that we use to measure temperature, and be able to comprehend some of the instruments that you use to measure pressure. Also understand the relationship between relative pressure, absolute pressure, gauge pressure, and atmospheric pressure. Okay, so conceptually, before we start, if I gave you the terms absolute pressure, gauge pressure, and atmospheric pressure, could you make an equation to set those parameters in the equation? How would we set that up? What do we think? So absolute pressure, gauge pressure, and atmosphere.
I think the absolute is just the other two added together.
Nice, right? So absolute pressure is going to be atmospheric pressure plus your gauge pressure. Good. All right. These are your references in the reading that everybody did. All right. So this is some examples of how conversions went wrong. In this first one, they lost this lunar module because they did improper calculations from metric to the standard system, and they crashed and burned. Right? This airline here, they also did improper calculations because it was their first aircraft. They converted to a metric system, so they thought they had double the fuel that what they actually had, so they had to perform an emergency landing. They almost ran out of fuel. Right? Luckily, nobody died. I think 2 people were injured, but no one died. And then the last one really is just an indication of in Disney, Space Mountain, whenever they were doing testing, again, they did metric system versus the standard system. They did wrong calculations, and then one of the trolleys derailed. Right. So know which system you're operating in. So quick conversion. We can do this kind of in our head, right? What's the acceleration due to gravity on Earth in feet per second?
9.81.
That's meters per second.
It's like 32.2.
Right, yeah, 32.2. So if we see this problem, how much would we weigh on the moon? If on Earth we weigh 200 pounds. Who's got a calculator or phone? 32.2, 5.3, tell you that's approximately 1/6. 1/6. I know it's ready for math.
32.9.
Nice, right?
33 pounds.
Right, just about 1/3, about 33 pounds. Does that make sense? So conceptually, you've seen it though. You saw that the number was smaller. You knew that the weight would be higher or lower.
Low.
Right, it would be lower. Okay, good. Right, don't stress too much about the equations. I want you to learn more the concepts, but all right. Did that make sense, everybody?
Sir.
Okay. Also, who's taking physics right now? All right. You guys heard of the term unit analysis, right? So if you're giving a conversion problem and you're kind of stuck, just look at the units and railroad track that across until you get your final answer. Okay. A lot of the times you can solve a problem, complex problems, just by doing unit analysis. Let's define temperature. How would we define temperature? We think we know the definition of temperature. How do we define that? Which minutes?
How much energy it takes to heat up a certain amount of material at 1 degree.
Okay, how much energy I gotta put in to heat up something? Okay. Anybody has a different opinion? Smart.
Intermolecular kinetic energy.
Oh, nice. Did we talk already?
Last class, sorry.
Okay. Nice. You close, right? Almost gave me the nuke definition. If you go nuke, you're gonna have to have the verbatim definition for it. But isn't that kind of crazy, right? A word that we use pretty routinely, right? Take your temperature. During COVID, we're checking temperature, but how do we define that? Like, what's the definition of that? When we asked to define it, it's difficult. But if we define it, it's a measure of the internal energy of a substance, right? The nuke definition is a measure of the random intermolecular kinetic energy of a system. So as it heats up, the molecules inside move faster, they move quicker, and we measure that with a thermometer. So it's a measure of the internal energy of that substance. Ways of measuring temperature. We have relative scale, right? A relative scale is in reference to something, or absolute scales. Fahrenheit, Celsius, examples of relative scales. And we see here, the reason why we have things like Rankine and Kelvin.